So let's talk simplifying rational expressions. Basically, once again, a rational expression is simply something that can be written as a fraction. Our fractions are going to come in terms of, in this first case, one integer over another. Second case, an expression over another expression. So in simplifying this, the general idea is you want to reduce whatever you can. Now, big emphasis on taking and factoring each term, and the only way you can reduce something is if you have a like factor and you can reduce it over multiplication or division. Now here's multiplication, here's division. I can reduce, we know 3 over 3 is 1. So I reduce that and I get 4/5. Now this is a real simple problem, real simple explanation. But the underlying theme is you may only reduce over multiplication or division, not addition and subtraction. For instance, just because I see a 10 and a 16 here doesn't mean I get to reduce those, because granted there is a division here, but I have two subtractions separating these terms from the other term. You may not reduce if there is a subtraction within that expression. It has to be the exact same factor. So once again, the tip is factor. GCF, 5. Bottom, x squared plus bx plus c. So we find out what multiplies to 16. Get you 6. That's an 8 and a 2. 8's positive, 2's negative. Now notice all multiplication, and a division. Exactly like factors reduce. 5 over w plus 8. Now this expression is good as long as w doesn't equal -8, because if w equals -8, then we have an undefined term of 5 over 0, no go. But we aren't setting this in an equation or anything like that. This is just what we call a restricted value. All right, so let's move forward. Similar problem. Again, I would rewrite this so that my x squared term is first. However, as I've told you before, I hate having leading terms that are negative. So what I'm going to do is I'm going to factor out a negative, say that's x squared minus 25 over 8x minus 40. So as you can see, I have a difference of squares on the top, that factors. On the bottom, I have a GCF of 8, which factors. All multiplication on top and bottom, division in between, any like factors can be reduced. All right, and I have opposite of x plus 5 over 8. And you can leave it like that. You don't have to distribute the negative through. There are no excluded values in this because 8 is the only term in the denominator. Thus, you can't divide by 0 in this case. So you'll notice in this example, we have two rational expressions multiplied together. And the rules of multiplying fractions is we can multiply numerator times numerator, denominator times denominator, which in this case would be a pain. We can also reduce numerator to denominator straight on top and diagonally, because I'd have multiplication and division. However, nothing's been factored yet, so let's go ahead and start that. We have an a squared and an a minus 6. We have an a plus 3, a minus 1. I have an a minus 1, an a minus 1. And then I have perfect squares in the denominator, 5a, and we'll go plus 2b, because that's a difference of squares, and 5a minus 2b here. So now we look and see what we can multiply together or reduce. This is not very clean. We're going to reduce the a minus 1 and the a minus 1, and I'm pretty much done with reduction. So in order to simplify, we could multiply all that out. I'd never ask you to do that. We can simplify it in what we call factored form. So we'll just write all the terms that are left down and call it a day. like so. All right, next. So in this example, we notice that we have a division of two fractions, in which case we know we have to multiply by the reciprocal of the term following the division sign. So let's get to work. I've got a minus b quantity squared. I'm going to take and guess and check this next term since I know there's only one way to get 5 and one way to get 2. A is in the front, B is in the back. I can go 2 here, but then I'll get 10, so I'm not going to do that. I'll put a 1 here and a 2 here. I need the biggest term to be negative, so that's this guy. That gets me a negative 5b and a positive 2b, or 2ab, excuse me, and that will get me my negative 3. Moving to the next term, I've got a difference of cubes, so a minus b starts, a squared plus ab plus b squared, and then I have a difference of squares on the top, so 5a minus 2b, 5a plus 2b, and now everything's in terms of multiplication and division. I look for my like factors. These are like factors, so I can reduce one of them and get an a minus b in the numerator. I'll just get rid of those. 5a plus 2b, 5a plus 2b gives me a 5a minus 2b left in the numerator. These are all gone. Oh, I didn't notice I've got another a minus b here, which would go with this guy. And I'm left with a squared plus ab plus b squared. So my final answer, let's clean that a little bit, is just the 5a minus 2b over a squared plus ab plus b squared. Now we move on to adding and subtracting rational expressions, and we're going to start at the very beginning, simplicity, and basically talk about form and function. All right. Whole idea behind this, depending on what middle school teacher you had. Some said, hey, just multiply the 6 and the 8 together. There's your common denominator, change numerators, so on and so forth. But that's really an inefficient way to get this done. All right. The proper way to go about this is look at the factors of the denominator. So I have 2 and a 3 here, and these are all 2's. All right. You can say 4 and 2, but I'm going to say 2, 2, and 2. All right. Kind of like you would in a factor tree, which I'm not going to get into because I'm not a fan of the factor trees. Now, next thing we do, we need a common denominator. And the lowest common denominator is the smallest number such that each term goes into that denominator. So I always usually write down 2 items since I have these 2 items here, and I say, okay, I got to have a 2 here. So I'm going to put 1, 2 in my problem. And that deals with those 2 because this has a 2 as well. Then I need a 3. So I've dealt with the 3. And what's left? I've got 2 2's left, so I need a 4. Now, the smallest number, which in this case is 24, is my LCD. Next, we have to change our numerators. So, in order to get from 6 to 24, I multiply by a factor of 4 to the numerator and denominator. Notice I'm multiplying by a form of 1, so this value will not change. In this case, I'm going from an 8 to a 24. I multiply by 3 over 3, which is again a form of 1, and I get 9 over 24. In adding, I keep my denominator the same, add the numerator. Long-winded for something you got in 5th grade, but the theory holds true for every addition and subtraction problem we're going to do today. And I'm going to go about that the same way every time. So here's another problem. Again, I want to look at the factors. Anything that's a multiple is a factor in this case. The only thing I need to break down is really the 8, which is 2 2, 2, and 2, and the 10, which is a 2 and a 5. All right. So now I write down my new term. I need this 2. I need this 5. And I have 2 2's left over, which is a 4. So the LCD is going to be 40 in this case. And that's for just the constant pieces. Now I need also an x, but I need more than an x because this has an x squared in it. All right, I need 2 x's. So I'm going to add an x squared to that. And I need a y, but I really need a y squared because if I only had a y, this y squared wouldn't fit. Like so. Now I have to go ahead and change my numerators. To get from 8 to 40, I multiply by 5. To get from x to x squared, I multiply by x. I had a y squared and a y squared. So I multiply by 5x over 5x, which is my form of 1, giving me 25x. To get from a 10 to a 40, I need a 4. To get from x squared to x squared, I don't need anything. And y to y squared, I need a y. And that's my form of 1 here. So this gets me 28y. Again, add the numerator. And keep the denominator. Nothing reduces because this is all linked by addition. Now in this term, you'll notice that the denominators are binomials, which means they're individual terms. They can't be factored. So this is like one thing by itself, and so is this. So those are independent factors from one another. The x, just because there's an x here and an x here, makes no difference. So when I now take and say, okay, let's make my common denominator, I have to have this x plus y represented because that's one unique term, or one unique factor, if you will. Likewise, I have to have the x minus y represented because that's also a unique factor. And then my LCD is just x plus y and x minus y. Don't feel the need to multiply that all out. So now to get from the x plus y to x plus y, x minus y, I need a form of 1, which will be x minus y. This I distribute, and I get x squared minus xy. I need a form of 1 here to multiply, which is x plus y. Again, I distribute through. This is an addition problem. Add the numerator, I get x squared plus y squared, which is not factorable, over x plus y, x minus y. Notice again, I may not reduce this because this is not the same as x plus y squared. Totally different. All right, this doesn't factor, so I'm done right here. Now we've got a subtraction, which is really no different. The only difference is going to be that I'm going to take an extra step to distribute and make sure I do things carefully. So let's go through and make sure all these denominators are factored, which they aren't. This goes to an x and an x plus y. This goes to x plus y, x minus y. So you'll notice there's no constants in this, but we have these binomial terms that are all distinct and separate. And then we have this lone variable sitting right here. So that's going to have to be included in the LCD. So I need that x, as we stated. I need an x plus y, and notice I have one here as well, but I still need it to be represented because it has to go into the LCD. And then I need this x minus y. Now I take and multiply by my form of 1. So I go from x and x plus y to x plus y, x minus y. I need an x minus y as my form of 1. It's a little uglier because I have to now FOIL. There's a 2xy minus an xy, which is just a positive xy, and then minus 2y squared. Next, in order to get from this step to this step, I need a multiple of x, which is not as difficult when I'm multiplying that out. So I get an xy and a minus 2x squared. Now, here's a step where I would suggest you do it very carefully and show your work in doing so. This is one term, it's subtracted, so this subtraction needs to be distributed through, because I have to subtract an xy and subtract a negative 2x squared. So when I write this out, I'm going to get x squared plus xy minus 2y squared minus xy plus 2x squared all over x and x plus y and x minus y. Now I clean things up. I look for my x squared terms. That's 3x squared. My xy terms are going to go away. Minus 2y squared over x plus y, and x minus y. The numerator does not factor, so there will be no reduction of more factors, and I should be done. In this next term, we're just going to keep going through repetition so you get an idea of what we're looking to do. We've got an x squared in common. I pull that out. Let's make that a little bit better. I have an x minus 5 left. I have an x in common. I have an x plus 5 left. So just like in the last example, we have some binomials and some isolated variable terms. Notice, in order for me to get an LCD, obviously I'm going to need the x minus 5. Obviously I'm going to need the x plus 5. And then where most people still make their mistakes is with this x and x squared. Yes, I definitely need an x, but I need the x squared because the whole thing has to fit into this LCD. If I just go with an x, the x squared doesn't go in. So I have an x squared and an x squared. All right. Change our numerators. Look for that multiple in form of 1. So notice I'm missing my x plus 5 here, giving me a 2x plus 10. And in this case, it looks like I'm missing an x and the x minus 5. So this is 2x squared minus 10x. Add like terms, 2x squared plus 8x plus 10 over x squared, x minus 5, x plus 5. Now, this is the first time we've encountered something that actually continues to factor. So I'm going to do that. I'm going to pull a 2 out. And then I look at that and I say, well, while that factored, it didn't really help to get any factor that reduces with the bottom. But as far as I'm concerned, it's good to go through that exercise, factor it out as far as it'll go, and see if there is anything in the numerator now, factor-wise, that reduces with the denominator. It doesn't in this case. You could leave this as an answer, or you can leave this as an answer. It doesn't matter. But again, I would go through that exercise of factoring completely the numerator out once you're done. Let's continue. I have an x plus 2, x plus 1. I get my LCD of x plus 2, x plus 1, x minus 2. I write it out twice. Get my multiples. I'm missing an x minus 2 in this case, giving me a 3x minus 6. In this case, it looks like I'm missing this whole, the x plus 2 and the x plus 1, which is really the trinomial. And that's going to be my form of 1 to multiply. So in this case, I have 3x squared plus 9x plus 6. And then I will distribute that negative to each term. So that gives me a 3x minus 6 minus 3x squared minus 9x minus 6 over my x plus 2, x plus 1, x minus 2. Combining like terms, so I'm going to start over here. I've got a negative 3x squared. I've got a negative 6x and a negative 12 over x plus 2, x minus 2, and x plus 1. Notice I've got some things in common again. I'm going to pull out a negative 3, leaving me with x squared minus 2x, plus 2x, sorry, plus 4, I believe. And that's going to be over x plus 2, x minus 2, x plus 1. Pretty sure I did that right. Hope I did that right. Notice, again, there's nothing that will reduce out because this term doesn't factor anymore. So again, you could have left it here or leave it here. Doesn't matter to me. But I like going through the exercise. Okay, now in this next example, right off the bat, I look at this and go, I don't like looking at that because I have my leading term, which should be the x squared, as a negative. So I'm going to take and rewrite this as negative 4x squared minus 1, like so. And now I'm going to rewrite my whole problem. So I've got x over 2x minus 1. This is a negative, and that's a subtraction. A negative times a negative is a positive. So this changes into an addition of 2x over 4x squared minus 1. And then this is plus x plus 1 over 2x minus 1. You don't have to do it this way, but I think it saves a lot of problems in the end. So we will take and factor. Just so happens that when I factor, I notice I have both these two terms. So my LCD is going to be 2x minus 1 and 2x plus 1 across the board. Notice I'll rewrite this 3 times. That's just me and my grinding kind of way. And then I go about and find my forms of 1. So in this case, it's a 2x plus 1, which leads me to 2x squared plus x. Nothing changed here. This is just a 2x. And then on the last term, just erase that because I don't need it. On the last term, I notice I've got to go 2x minus 1, needing a FOIL. So when I do that, that's 2x squared. Minus x plus 2x is plus 1x minus 1. Add your like terms. This is a 4x squared. X2x is 4x. Only one constant, minus 1 over 2x plus 1, 2x minus 1. And so in this case, make sure I did that correct. Yeah, this is not going to factor. If this were a plus, it would. Would have been a good problem. Anyways, here's my answer. So in our last example, we have a couple denominators that are a little more difficult to factor. And you can factor those any way you like. I'm going to do it by guess and checking just for the fun of it. And let me give you a hint as to what I'm going to look at. I look at the second term because I know this is going to have a factor of 2n in it. And then I'm going to need a -6, which means probably 6 and a 1 or a 2 and a 3, but I need a 1 in the middle. So I'm going to go with, if I put a 3 here and a 2 here, that's going to do it because I get 4 and -3, which is 1. Now, the reason why I did that is because likely 90 out of 100 times, I would say, that one of these factors is probably in here. So I'm going to go with the 2n and guess 3n. And then I'm going to need a -12 and a -1 right here. So if I put, let's go 3 here and a 4 here. And notice that's a +8 and a -9, and I'm done. So that was a good guess. If you want to do a 5-step to that or do any other method of factoring to get that, entirely up to you. So now I've got to pick my LCD. Notice these two are already in common. I'm going to need that though, but I need a 3n plus 4, the 2n minus 3, and the n plus 2. Then I figure out what my multiple of 1 is going to be. And in this case, I'm missing the n plus 2, which gets me n squared plus 4n plus 4. This term, I'm missing a 3n plus 4, giving me a 9n squared. 12 and 12 is 24, n and a 16. I combine my like terms, that's 10n squared, 28n, and 20 over n plus 4, 2n minus 3, and n plus 2. I can factor, pulling out a 2, having 5n squared, plus 14n plus 10. And then I would have to actually check to see if that second term in the numerator actually factors. And I'll just go ahead and use the 5-step for fun. So we'll do it over here just so nobody's confused. That's going to be 5n squared plus 14n plus 50. And is there anything that multiplies to 50 and gets you 14? 2 and 25 won't work. 4 doesn't work. 5 and 10. I think that's it. Right? So that's not going to factor. Therefore, this is done. And that's all we've got for today.